focus our discussion on determining the similarity of triangles. But first, we state a postulate regarding this.
Postulate? So we will not prove this statement, won't we?
You're right. Recall that postulates are statements which are accepted to be true. So, here it is. Gabez, will you please read the statement?
Okay, ma'am. AA postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar.
Let us now analyze what this statement is telling us. What is the hypothesis of this statement, Denise?
Two angles of one triangle are congruent to two angles of another triangle.
Very good. What about the conclusion, Paolo?
The two triangles are similar.
Correct. The AA postulate is better illustrated in the given slide. Note that in the given figure, it is assumed that angle A and angle D are equal, and angle B and angle E are equal. With these given conditions, we can conclude that triangles ABC and DEF are similar. By the way, we can write this in symbols as triangle ABC is similar to triangle DEF. Let us now use this postulate to determine which pairs of triangles are similar. Who would like to analyze the first figure?
I'll do it. We are comparing triangles STO and ERO. Since it is given that line segment ST is perpendicular to line segment TR, line segment ER is perpendicular to line segment TR, then both angles T and R are right angles and hence are equal in measure. Moreover, angles SOT and EOR are vertical angles and so they must be equal. We see that the two triangles have two corresponding angles that are equal. By using the AA postulate, we conclude that triangle STO is similar to triangle ERO.
Very good, Denise. Alright, we now go to the second figure. The triangles being compared here are triangles EWI and ERN. Anyone?
I can say that the two triangles share the same angle E, and so we are sure that they have a pair of equal angles. Angles R and W are equal too, so they are similar triangles.
What makes you conclude that angles R and W are equal?
They look the same, don't they?
It is not enough to make conclusions based on appearance, and you know that, Gabez. So, think. Look at the given conditions and see which of these can be used.
Well, it is given that line segment RN is parallel to line segment WI.
That's right. What conclusion can we make out of this? Anyone?
We can treat line segment EW as a transversal cutting line segment RN and line segment WI, so that angles ERN and EWI are corresponding angles. Since line segment RN is parallel to line segment WI, then we can conclude that any pair of corresponding angles are equal, and therefore, angles R and W are equal. Gabez's conclusion is right after all.
Why didn't I think of that? Thanks, pal. You're my savior.
Very good, Miss Beth. Indeed, triangles ERN and EWI are similar. We now move to the third figure. Any volunteer?
I'd like to try this, ma'am.
Okay.
We are comparing triangles TRU and TEU. Both are right triangles, since it is given that line segment TU is perpendicular to line segment RE, forming the right angles TUR and TUE. But I guess that's the only valid conclusion I can make out of this. And so I am missing another pair of equal angles.
Okay, you must be referring to right angles TUR and TUE. Who would like to make a comment?
I think that Joyce is right in saying that the only conclusion that can be made out of the given conditions is that angles TUR and TUE are right angles, and so they must be equal. there is no sufficient information that can be used to compare other pairs of angles. So I think we can't make any other conclusions regarding the similarity of triangles TUR and TUE.
Right. There is no sufficient information given for us to conclude that these triangles are similar. Remember that we need two pairs of equal corresponding angles in order to use the AA postulate. Class, aside from the AA postulate that we have just studied, there are other possible ways of checking whether two triangles are similar or not. We now discuss the SSS and SAS theorems. Let us start with the SSS theorem. Joyce, will you please read the statement?
Okay, Sss Theorem. If the measures of the corresponding sides of two triangles are proportional, then the two triangles are similar.
Let us examine this statement by identifying the hypothesis and conclusion of the theorem. Can you identify them, Paolo?
The hypothesis states the condition that the measures of the corresponding sides of two triangles are equal. The conclusion is that these two triangles are similar.
Correct. Examine the two triangles shown in this slide. If triangles ABC and DF satisfy the hypothesis of the SSS theorem, then how are the sides of these two triangles related? Denise?
The corresponding sides are supposedly proportional, so AC over DF is equal to AB over DE is equal to BC over EF.
Very good, Denise. Now, we prove the theorem by a simple construction. First, we locate a point H on side DF of triangle DF so that HF is equal to AC. Then, we draw line segment HI so that HI is parallel to DE. Now, treating side DF as a transversal cutting HI and DE, what can you say about the corresponding angles, 1 and 2? How about you, Gabez?
Lisbeth used that concept a while ago. I remember now. We have drawn line segment HI so that line segment HI is parallel to line segment DE, and therefore, corresponding angles 1 and 2 must be equal.
Very good, Gabez. Alright, this time, let us compare triangles DEF and HIF. Any observation? Yes, Joyce.
Triangles DEF and HIF are similar, and this time I can prove that.
Good. We can't wait to hear that.
First, I noticed that the two triangles have a common angle, which is angle F. Second, we have seen that angles 1 and 2 are equal. This means that we can use the AA postulate to justify the conclusion that triangles DEF and HIF are similar. End of proof.
Good work, Joyce. I am impressed.
Thanks.
Are we done yet?
No, ma'am. Our main goal is to prove that triangles ABC and DEF are similar. So far, we are successful in proving that triangles DEF and HIF are similar. So, I'm afraid we are not done yet, Joyce.
Well, Denise is right. But there is no need to hurry. We will get there in a short while. Going back to the conclusion you made, Joyce, the triangles DEF and HIF are similar. Would you like to state some more conclusions?
I think I will need Denise's help.
That's okay, Joyce. I'm willing to help. I just think that we need to prove that the corresponding parts of triangles HIF and ABC are equal. Maybe we can write equations that show that the corresponding sides of DEF and HIF are proportional. So, HF over DF is equal to HI over DE is equal to IF over EF.